Yeah, good afternoon, children.
Good afternoon, ma'am.
Good
Good
afternoon.
afternoon, ma'am.
Good afternoon, children. Yeah, last class on Thursday, we did the first five questions in this presentation. I had shared, I think this one we understood in the class. We discussed this answer in the class, but I think you did not have time to write down the answer. So I shared the image on WhatsApp. Have you all completed, children? Writing this one in your notebook? No?
No, ma'am.
Okay. Okay, see, because everything is important. This is very important. So I'll just give you 2 minutes. I'll wait, children. Please write down this. Please write the answer, children, before we proceed with the next one. I believe all of you are writing, children. Okay, Navya, got your message. Done, children?
Yes, ma'am.
Finished? Yeah, I'm sure all of you have access to your phone now. I want to make sure that I was not waiting like a dumb, believing that you're writing. So all of you take pictures of this particular answer and share it on WhatsApp with me now. Rakshita, Krish, Ritik, and Navya was not there in the last class, so I don't know if you have completed the notes of the last class. Prajit, Danya, Florentina, Sashank, Raja. Sashank is from 2 different devices. All of you quickly share the image of what you've written now.
Ma'am, I joined just now.
Ma'am.
YouTube. Okay. Yeah, see, very good. Prajit. Very nice.
Ma'am.
Very good, Prajit. So impressed. Very good.
Thank
Rakshita.
you.
Okay, Navya, I've actually shared the recording on WhatsApp in the group. So please find it, watch the recording and then write down the contents in your notebook. It is simple to understand. Just in case you have any clarifications, you can just text me on WhatsApp after you watch the recording. If you have further doubts, you can text me on WhatsApp. We can discuss them. So Prajit was the first to send. Rakshita only 1 page. That's incomplete. Danya. Okay, but no figure. All right. That's all. I don't know what the others were doing. So I think this is not a good idea. To wait for you to complete is not a good idea because the percentage of response is very small. Good, Prajit and Danya. All right. Continuing with the next one. A round balloon of radius r subtends an angle alpha at the eye of the observer. A round balloon of radius r subtends an angle alpha at the eye of the observer. Okay. So this is the observer. The height of the observer is not known. The height of the observer is not known. So this is the position of the observer. In fact, this is the eye of the observer. This is the level ground. This is the level ground. This is the eye of the observer. So there's a balloon in the air and the observer looks at the balloon. The angle subtended by the balloon at the eye of the observer. So this is his vision. This is the maximum vision he can have of the balloon. All right. So this angle is measured to be alpha. This is the eye of the observer. See, this is his vision. The question says a round balloon of radius r subtends an angle alpha. It subtends an angle alpha at the eye of the observer. This is not the angle of elevation. It is not the angle of elevation. The angle subtended by the balloon at the eye of the observer. I'll give you one more example to, explain this better. Just listen to this first. So this is the position of the observer. This is the vision. This is the vision of the observer. The 2 line segments which I've shown here. Okay, this one. So this is how the observer views the balloon. This is how he views the balloon. The angle made at his eyes is alpha. The radius of the balloon R, radius R, center, and there's a point on the circumference, radius R. While the angle of elevation of its center is beta. The angle of elevation of its center is beta. This is the center of the balloon. This is the center of the balloon. This is the height of the center of the balloon from the ground. This is the height of the center of the balloon from the ground. The height of the center of the balloon from the ground. Okay. So this is the center of the balloon. This is the height of the center of the balloon from the ground. Now the elevation of the center. The elevation of the center is beta. So this is the eye of the observer, and he's looking at the center of the balloon, the center of the balloon. So use a line segment to connect the center of the balloon, the point observed, and the eye of the observer. From the eye of the observer to the point observed, he looks at the center of the balloon. All right. So this is the line segment connecting the center of the balloon and the eye of the observer. The angle of elevation is beta. The angle of elevation of the center is beta. So this is the line of sight. This one is the line of sight. This is the horizontal. This one is beta. This one is beta. This angle is beta. The angle between the line of sight and the ground and the horizontal is beta. So prove that. You can just show the other radius here if you want. So we need to prove that the height of the center of the balloon is given by r sine beta cosecant alpha by 2. So there are two angles mentioned here, one alpha, the other beta. Alpha is not angle of elevation. It's the angle which the balloon subtends at the eye of the observer. So this vision, the observer looks at this is the entire vision of the balloon at the eye of the observer. That angle is alpha. And then the observer looks at the center of the balloon. So connect the eye of the observer in the center of the balloon. That's the line of sight. The ground is the horizontal. The angle between the line of sight and the horizontal is beta. The angle of elevation is beta. The angle of elevation of the center is beta. Now to complete the triangle, we drop a perpendicular. From the center, we drop a perpendicular to the ground, which represents this one. We drop a perpendicular from the center of the balloon to the ground, which represents the height of the balloon, height of the center of the balloon from the ground, height of the center of the balloon from the ground. Now with this figure, we'll have to show that this one, this height h is given by r sine beta cosecant alpha by 2. Sorry. Let's just use some variables to represent line segments. So we'll call this one. Okay, we'll call OA as H. We'll call OA as H. Okay, let's mark as and when needed, children. Let's start working. Now look at the ratios used in the result. The ratios in the result are sine beta and cosecant alpha by 2. So you have to use the same ratios in the triangle. You will have to take up the relevant triangles and use this ratio, not tan alpha, tan beta, what we normally do. So whatever ratios are in the result, you should find the same ratios using the relevant triangles. So we need to find sine beta and cosecant alpha by 2. Before that, let's try to use some properties and get more information from what is actually given to us. Now, from the chapter circles, we know that equal tangents are equally inclined to the line segment joining the center and the external point. Circle, this is the line segment joining the center and the external point. These are the two tangents. Tangents. We know that this angle is equal to this angle. circles. P is an external point. Circle with center O. P is an external point. A point lying outside the circle. OP is the line segment joining the center and the external point P. PA and PB are two tangents from P to the circle. We know that PA is equal to PB because tangents from an external point to the circle are equal in length. We also know that this angle is equal to this angle. The tangents are equally inclined to the line segment joining the center and the external point. This is the line segment joining the center and the external point P. The tangents, the tangents, this is one tangent, this is the other tangent. These two tangents, they're equally inclined. That is, they make equal angles. With what? With the line segment joining the center and the external point. The two tangents, they make equal angles with the line segment joining the center and the external point with this line segment. That means this angle is equal to this angle. This is the angle made by this tangent with the line segment joining the center and the external point. And this is the angle made by this tangent with the line segment joining the center and the external point. So these two angles are equal. So here, if this whole thing is alpha, this one is going to be alpha by 2 and this one is going to be alpha by 2. Because B is like the external point. OB line segment joining the center and the external point B. CB and DB tangents. CB, DB tangents. So if this whole angle is alpha, if this whole angle is 60 degrees, then this will be 30, this will be 30. In the same way, this whole angle is alpha. So this is going to be alpha by 2 and this one alpha by 2. Also, we know that the tangent and the radius at the point of contact are perpendicular to each other. So 90 degrees here. Radius tangent 90. Here also it's 90. You can take any one. Radius and tangent at the point of contact 90 degrees. They're perpendicular to each other. So 90. So actually to use trigonometric ratios, we need right triangles. We have this angle alpha by 2. That's not enough. We need to have alpha by 2 in a right triangle so that we can use trigonometry or the trigonometric ratios. It's not enough if you have this angle alpha by 2. This angle alpha by 2 must be in a right triangle. And that is why we use the theorem to mark off this angle as 90 degrees. So now OCB is a right triangle. OCB is a right triangle. And you can use cosecant alpha by 2 and write the ratio of the sides. Now for beta, OAB is already a right triangle. For beta, beta is in the triangle OAB. Beta, this angle beta is in the triangle OAB, which is already a right triangle. So now we are ready to use the trigonometric ratios. We have the two angles, alpha by 2 and beta in right triangle. So we can use the ratios now. So cosecant beta by 2. Any ratio first. Cosecant alpha by 2, sorry. Cosecant alpha by 2 is equal to sine is opposite by hypotenuse. Cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So hypotenuse by opposite. So this is the hypotenuse because this is the opposite of the right angle. Hypotenuse. This is the hypotenuse. So opposite, hypotenuse by opposite. So which is OB by OC. Yes or no, children? Is this right? You can, so now that we have used OB, you can just call it X. You can just call it X. And OB, this one, OC is R. So cosecant alpha by 2 is equal to OB. We have just called it X. And OC is the radius R. So as I've told you in the last class, you write the expression that is, now should you cross multiply and write R is equal to or X is equal to. Now you know that in this final result, we don't have X. X is not a part of the final result, r sine beta cosecant alpha by 2. So you don't want X. So write X is equal to cross multiply and write X is equal to r cosecant alpha by 2. Cross multiply and write X is equal to r cosecant alpha by 2 because we don't want X. Why we don't want X? Because we don't see it in the final result. And also X is a variable which we have assigned in this figure. It was not given in the question. So cross multiply and write X is equal to whatever you don't want, have that alone on one side. What you don't want in the final result, have that alone on one side. So X is equal to, on cross multiplying, r cosecant alpha by 2. Okay. Now we'll find the next one. That is sine beta. So sine beta is equal to sine beta. It's in the triangle OAB. Sine beta is equal to opposite by hypotenuse. So directly I'll just write h by what, children?
OB.
OB, which is x. So cross multiply, you get, when you cross multiply, you get h is equal to x sine beta. H is equal to x sine beta. Now you should realize that h is what you want to find. See, what is that you want to find? You want to prove that the height of the center of the balloon, that is h. See here, h. H also we only marked, but that's needed in the final result. H we marked. H was not given in the question. We use the variable h. But we see that we need that in the final result. We need to prove that h is equal to r sine beta cosecant alpha by 2. Prove that the height of the center of the balloon, which is given by h, which is h here. You need to prove that h is equal to r sine beta cosecant alpha by 2. So we've got h is equal to x sine beta. Now what is x? What is x? H is equal to x is r cosecant. Go back to the earlier one. What is x? Here it is. What is x? R cosecant alpha by 2. So substitute that. Instead of r, say instead of x, here is x. No, we don't want x. So instead of x, you write r cosecant alpha by 2 and the sine beta as it is. Sine beta. This is using 1. So which means h is equal to r. We'll write it in the order it is in the question. R sine beta cosecant alpha by 2. This is what we have to prove. So we've used two theorems here. One is OC is perpendicular to BC. One is OC is perpendicular to BC because OC is the radius and BC is the tangent. A radius and tangent at the point of contact perpendicular to each other. Why we had to use this? Because we want a right triangle. So we needed to show that an angle is 90 degrees. In the triangle, we have alpha by 2. There's a triangle in which we have this angle alpha by 2, but that one is not a right triangle. It was not given to be a right triangle. So we just want to find if one of the angles can be 90 degrees so that it is a right triangle and so that we can use trigonometric ratios. So that's one theorem we've used, and the other one is this whole angle is alpha. Equal tangents are equally inclined to the line segment joining the center and the external point. So that way we have alpha by 2 here and alpha by 2 here. So we use these two theorems. And then I also told you that you need to use the ratios which are in the final result. In the final result, we have sine beta and cosecant alpha by 2. So in the triangle OAB, where you have beta, you should find sine beta. And in the triangle OCB, right triangle OCB, where you have alpha by 2, you should find cosecant alpha by 2. And what are you trying to prove? We're trying to prove that h is equal to height of the center of the balloon from the ground. So h is equal to, so you want h. You'll have to show this only. H is equal to what you don't want. X you don't want. But what is x from the earlier one? R cosecant alpha by 2. So substitute that. Please write down, children. As you write, any more clarifications, please ask me. Okay, Rakshita, I got your images. Very good. Vishnutik has also sent. Done writing, children?
Completed.
No, ma'am.
Okay. Yeah, children, done?
Completed, ma'am.
Okay. So let's see the figure again. Round balloon. The angle subtended by the balloon at the eye of the observer is alpha. This is the ground level. This is the height of the balloon from the ground. This is the angle subtended. Alpha is the angle subtended by the balloon at the eye of the observer. This is the ground level. This one. This is the center of the balloon. This is the height of the center of the balloon from the ground. This is the line segment connecting the center of the balloon and the eye of the observer. This is the radius of the balloon. This is 90 degrees by the theorem, because radius and tangent, so 90 degrees. Again, this whole angle is alpha. By the theorem, it's alpha by 2 here and alpha by 2 here. And beta is the angle of elevation of the center. So that means this is the line of sight. This is the ground level. This is the line segment connecting the center of the balloon and the eye of the observer. So between this line and the ground, the angle is beta. You don't have to join this radius. If you want, you can join. It's okay. It's okay if you don't show this radius. Next one. From an aeroplane vertically above a straight horizontal road. Okay, so let's take a straight horizontal road. Aeroplane. This is the position of the aeroplane. From an aeroplane vertically above a straight horizontal road, the angles of depression of two consecutive milestones. Two consecutive milestones, meaning the distance between any two consecutive milestones will be 1 mile. Consecutive meaning one after the other. So two consecutive milestones, meaning the distance between these two stones is 1 mile. Okay, the angles of depression of two consecutive milestones on the opposite sides of the aeroplane. So let's say that this is the position of one milestone and this is the position of the other milestone. This is the aeroplane. So an observer from the aeroplane looks at the two milestones which are on the opposite sides of the aeroplane. So let's connect this one, which is the altitude of the aeroplane from the ground, the height of the aeroplane from the ground. So this is the position of one milestone A. This is the position of the other milestone B. And the distance between A and B is 1 mile because they're two consecutive milestones. Angles of depression. So we need to take the line of, we need to take the horizontal, which is this one, through the eye of the observer who's in the aeroplane. This is the horizontal. Now the lines of sight. The line connecting the eye of the observer and the object observed. Where is the angle? Where is the angle of elevation? Sorry, where is the angle of depression? It's between the horizontal and the line of sight. This is the horizontal, this is the line of sight. So here is the angle of depression. This is the horizontal. This is the horizontal because the observer is here in the plane. This is the horizontal, not the ground level. The angle between the horizontal and the line of sight, which is the line of sight connecting the observer and the object observed. This is the line of sight. Between these two lines is the angle of depression, which is alpha in one case and beta in the other case. So this one is alpha. This one is alpha. And again, this is the observer. This is the other milestone observed. So this one becomes a line of sight. The angle between the horizontal and the line of sight is the angle of depression, which is beta. So which means this is the alpha and this is beta. So that's what is given to us. From an aeroplane vertically above a straight horizontal road, the angles of depression of two consecutive milestones on opposite sides of the aeroplane are observed to be alpha and beta. See, you can mark alpha here also. Any side. You can even take alpha here and beta here. You can take alpha here and beta here. That's not going to give you an incorrect solution. That's fine. Alpha, beta on any side. Now show that the height of the aeroplane above the road, that means this one, is given by tan alpha, tan beta by tan alpha plus tan beta miles. So I'll just tell you how it goes. You can use a presentation and understand. Now this is 1 mile. You can, call this. You can call this one as X. This one as Y. Okay. You can call this as X. That is AD as X and BD as Y. So using one triangle, using this triangle, using this triangle and tan alpha, because that is the ratio we see in the final result. So using this triangle ACD and tan alpha, write the ratio, then write X is equal to something. Similarly, using this triangle, write Y is equal to whatever. Now add X and Y. Find X from the first one, Y from the second one. Then you perform this X plus Y is equal to. Now what is X plus Y? 1. 1 mile. So 1. You don't have to write the unit. X plus Y is 1. On working this, you should solve for H because you've called H to be the height of the aeroplane above the road. So you must work this X plus Y is equal to, you have an equation. You must work this for H. You must work this and find H is equal to whatever. You can do this in a different way also. Please work this first. So the diagram, as we've understood, then you can see from one triangle, find X. From the other triangle, find Y. And then find X plus Y. X plus Y is 1 because X plus Y is equal to 1 mile. So 1. Then what should you do with this equation? You should work this equation and find H. Why H? Because we have to show that the height of the aeroplane above the road. That is, we'll have to get the answer like H is equal to something. H is equal to, and you must get H is equal to, this expression. And that's what we've got here. See. Yeah, please work, children. No hurry. It's not blindly copying from the screen. Please take your time, go through the answer, and then write down. I've told you the sequence. I've just explained the flow of the answer. Please understand the same way and work it out. So children are talking about the working here. X plus y. So you've got this expression for x and this one for y. So we need to work x plus y. H is common in the numerator. So bring out h common. So then you'll have 1 in the numerators. Then common denominator, tan alpha, tan beta is a common denominator. So then you'll get tan beta plus tan alpha by tan alpha, tan beta. Now I've just changed the two sides. I've just exchanged both the sides. So I've just brought this to the left-hand side and taken this to the right-hand side. That's all. Exchanging the two sides. So this one which is in the RHS, get it to the LHS. And this one which is in the LHS, take it to the RHS. So just exchange the sides. And while doing that, here we have tan alpha, tan beta plus tan alpha. So I've written that as tan alpha plus tan beta. A plus B, B plus A, both are the same. So now H is equal to, see, if you have this, you have H into A by B is equal to 1. Okay, this one looks something like this, right? H into A by B is equal to 1. So when you transpose A by B, H will be equal to 1 divided by A by B. 1, because this fraction will, this in multiplication here, will go for division to the other side. 1 divided by A by B. So that is H is equal to 1 into B by A. So 1, anything into 1 is the same thing. So you can ignore this. So H is equal to B by A. H is equal to B by A. So that's what it is. This one becomes its reciprocal on the other side. So H is equal to, you can see, on the other side, this one becomes its reciprocal. On the other side, this becomes its reciprocal. H is equal to tan alpha tan beta divided by tan alpha plus tan beta. This is simply exchanging both the sides. Then H is equal to, this is a fraction here. When it goes to the other side, it becomes its reciprocal. I'm just showing you a similar example. So when you have H into A by B is equal to 1, H is equal to 1. This into A by B, on the other side will become reciprocal, B by A into B by A. Into B by A. So 1 into B is B. So B by A it is. So that's what happens here. This one becomes its reciprocal on the other side. So we proved that H is equal to tan alpha tan beta by tan alpha plus tan beta miles. It can also be worked like this. So you can also do it like this. See here. Supposing you call this one as x and the rest of it as 1 minus x, because BD is 1 mile. BD is 1 mile. So if BC is x miles, then CD will be 1 minus x miles. BD is 1 mile. So if you assume this one is x, the rest of it will be 1 minus x. So here what you have to do, take up this triangle, find tan alpha, and then write x is equal to h by tan alpha. Okay. See again, why we write like this, I told you in the last class. We need this and this in the final result. We need tan alpha in the final result. See here. And we need h also, because show that the height of the airplane above the road, that is h. H is equal to this is what we'll have to prove. So we need this also in the final result. What all you need, you keep it on one side. What you don't need, put it on the other side. All that you need, keep them on one side. That one thing which you don't need, put that on the other side. So we need h and tan alpha. Tan alpha is here in the result. And h because we'll have to show that the height of the aeroplane above the road. So h is equal to. So from the first equation, write x is equal to h by tan alpha. Now take up the second triangle and find tan beta. And here what you do, where you have x, because you know you don't want x. You don't want x. So where you have x, you replace it with h by tan alpha. That's all. In the second triangle, where you have x, replace that with h by tan alpha and work that. So you're working to find h. You're working to find h. So as you work, you will find that more than one term has h. More than one term has h. So you must have all the h terms on one side and the non-h terms on the other side. So you can see here after substituting, see here we have cross multiplied tan beta minus, please look at this step. Look at this step, cross multiply. So you get tan beta minus minus x tan beta. When you cross multiply, tan beta into 1 is tan beta. Tan beta into minus x is minus x tan beta is equal to h. Now substitute. What is x? H by tan alpha. This one is h by tan alpha. So you can see tan beta minus x is h by tan alpha. So h by tan alpha, you can see it here, h by tan alpha, and this tan beta is equal to h, is equal to h. So now how do we proceed? LCM, common denominator, tan alpha is a common denominator. So you get tan alpha tan beta. Tan alpha tan beta minus h tan beta by tan alpha is equal to h. Now cross multiply. Cross multiply. So tan alpha tan beta minus h tan beta is equal to h tan alpha. So now there are three terms. There's one term here, there's one term here, and one term here. So the LHS has two terms, the RHS has one term. Of these three terms, there are two terms with h. There are two terms with h. So gather the h terms on one side. Gather the h terms on one side. So what I've done is in the next step, I've just exchanged the positions. I've written h tan alpha here in the LHS and this one in the RHS. I've got this to the left hand side and this one taken this to the right hand side. Just exchanging the two sides. Then gather the terms that have h on one side. So h tan alpha, h tan alpha. This one transpose. So it will be plus h tan beta. Minus h tan beta comes to the other side as plus h tan beta is equal to tan alpha tan beta. So the idea here is to collect the h terms, the terms that have h on one side, and the terms that don't have h keep it on the other side. Because you're working to find h. The height of the aeroplane above the road is given by h. You're working to show that h is equal to this expression. So you're solving for h. So have the h terms on one side and keep the non-h terms on the other side. So now take out h common. Take out h. This is the procedure always. You're working to find h. All the terms that have h keep on one side. The terms that don't have h on the other side. And then take out h common. Whatever you have to find, if it is in more than one term, take out that h common. Take out that common. Only then you can solve for it. So take out h common. And then you get this. And then h is equal to tan alpha tan beta by tan alpha plus tan beta. Yeah, please write down this also, children. Please write this. As you write, understand. You don't have to write the question again. It's the same question. Draw the figure and take down the working. As you write, please understand. Finish writing, children?
Yes, sir.
Okay. Completed, children?
Yes, ma'am.
Okay.
Complete.
Yeah, good. All right, next one. From the top, 1 second, let me take a different situation. 1 second. Yeah. Okay, let's just do this one. Where did we start? 7, no? 8, 9 I have to do. Okay, this is 10. Okay. A ladder rests against the wall at an angle alpha to the horizontal. This is alpha, children. It looks very much like a. This is alpha. A ladder rests against a wall at an angle alpha to the horizontal. So ladder. So this is the ladder. Sorry, this is the ground, the wall, and ladder. And ladder. A ladder rests against a wall at an angle alpha to the horizontal. Its foot is pulled away from the wall. Its foot, this is the foot of the ladder. This is the foot of the ladder. This is the top of the ladder. This is the foot of the ladder. Its foot is pulled away from the wall. The foot is not taken closer to the wall. It's pulled away from the wall through a distance A units, so that it slides a distance B down the wall, making an angle beta with the horizontal. So its foot is pulled away from the wall like this. Now its foot is here. The distance, moved is A units. The foot is pulled away from the wall through a distance of A units. This is the foot of the ladder. It's pulled away from the wall through a distance of A units. So this one is A. Now, when you pull the ladder like that, what happens? The top of the ladder, it slides down the wall. It slides down a distance B. It slides down a distance B on the wall. So now this is the top of the ladder. Now this is the top of the ladder. This is the foot of the ladder. So connect the top of the ladder and the foot of the ladder. So this is the ladder. And now it makes angle beta with the horizontal. This is the same ladder. This is the same ladder. So the hypotenuse in the two triangles, they have the same length. In the two triangles, the hypotenuse, they have the same length because in both the triangles, the hypotenuse represents the ladder. So wall, ground, ladder, angle, alpha. Foot of the ladder pulled away from the wall through distance of A units. So the top of the ladder slides down the wall through a distance of b units. So now this is the top of the ladder. This is the foot of the ladder. This is the ladder. It makes an angle beta with the horizontal. So with this information, we'll have to show that A by B is given by cos alpha minus cos beta divided by sin beta minus sin alpha. So children, I'll just explain this from the end. So the thing is, we'll have to find A by B. Okay, you'll have to find A by B. So what we'll do, we'll find A, we'll find B, and then we'll perform A by B. We'll find A, see it, we'll find A, we'll find B, and then we'll perform A by B. So now, before we find A and B, let's apply all the trigonometric ratios in the right triangle. So both the triangles are right triangles because the wall and the wall and the ground are at right angles to each other. So we already have two right triangles. All right. Okay. So now let's apply all the ratios. What are the ratios we need to find? We need to find sin alpha, sin beta, cos alpha, and cos beta. That is, if you take up the angle alpha, you should find sin alpha, cos alpha. If you take the angle beta, you should find sin beta, cos beta. So take up this triangle, which has alpha in triangle ABE. In triangle ABE, find sin alpha and find cos alpha. Sin alpha is opposite by hypotenuse. See, this is the opposite side. Opposite. X plus B. By hypotenuse, I've called it Z. I've not marked there. I forgot to mark, so that's what I've written here. AE is equal to CD, is equal to CD, because both of them represent the ladder, is equal to Z. I've written here, is equal to Z. So the ladder is Z. The ladder is Z. Okay, so sin alpha is equal to opposite X plus B by Z. Cos alpha is equal to adjacent by hypotenuse, so Y by Z. Then take up the other triangle BCD, which has beta. BCD, which has beta. So sin beta, opposite by hypotenuse. Opposite is X by hypotenuse Z. Then cos beta, adjacent by hypotenuse. This is the adjacent side. See, this is the triangle which has beta. This is the triangle. So cos beta is equal to adjacent A plus Y by hypotenuse Z. Okay. So we found all the ratios, all these ratios. Sin alpha, cos alpha from one triangle, sin beta, cos beta from the other triangle. Now, we have a plan. Now we have to find an expression for A and an expression for B, and then we are going to divide A by B. Okay, so that's the plan. So now we have to find A. So where is A? Where is A? A is here in this one. And where is B? B is here in this one. So you can find anything first. You can find A and then B, or find B and then A, but you have to find A and B. Okay, so I've taken up the first one, this one. From this, I've found B. What is B? When you cross multiply this, children, what do you get? Here, B plus X. When you cross multiply this one, you will get B plus X is equal to Z sin alpha. I'll write it now. From one, this is one, children. When you cross multiply, you'll get B plus X is equal to Z sin alpha. So B is equal to Z sin alpha minus X. So we found B. Right? Now, when you look at the result, we don't have X and Y are something which we have used. It's not in the final result. So we'll replace X also. What is X? What is X? Can you see this one? X is equal to Z sin beta. Can you see from here, from 3? From 3, X is equal to Z sin beta. So X is replaced with Z sin beta. So you can take out Z common now, and you get sin alpha minus sin beta in the bracket. We have to take up the first one because the first one has b. Cross multiply. When you cross multiply, you get b plus x is equal to z sine alpha. So we have to find b. So b is equal to z sine alpha minus x. Now x is not there in the final result. So where is x here? See, this one has x. What is x from this? When you cross multiply, x is equal to z sine beta. So replace x with z sine beta. That's what I've written using 3. Using 3. So now when you take out z common, you will get b is equal to z common sine alpha minus sine beta in the bracket. So that's about for b. Now let's work for a. Let's work for a. Where is a? A is in 4. See here, a is in 4 here. So when you cross multiply, you will get a plus y. A plus y is equal to z cos beta on cross multiplying. Correct? On cross multiplying the fourth one, we get a plus y is equal to z cos beta. So a is equal to z cos beta minus y. Now what is y? From which one can we find y? This one. Using 2, we can find y. What is y? Y is equal to z cos alpha. Y is equal to, using 2, y is equal to z cos alpha. So here, instead of y, we write z cos alpha using 2. Instead of y, we write z cos alpha. So children, see, what you should observe is we are not using anything more than once. We are not using the same equation more than once. This one we used to find b. We use this one to find b. And we use this one to substitute for x. Okay. Then we used this one to find a. And we used this one to substitute for y. That's all. We've used everything only once. That's how normally it is. We don't use the same information more than once. We don't use the same information more than once. We used this one to find b, this b, and this b had x in it. So we used this one to replace for x. X is equal to z sine beta. After that, we used this one to find a. And then we used this to replace y. To replace y, we use this. So like this, finally, we have a is equal to, on taking z common, a is equal to z in the bracket cos beta minus cos alpha. I told you, we substitute for y. We substitute for y. Y is equal to, using this, y is equal to z cos alpha, and then take out z common, you get cos beta minus cos alpha. So now we have found the expressions for a and b. We found expressions for a and b. Now divide a by b. So write a, this is a, write that. And then b, this is b, write that. So z and z gets cancelled. And then what you see is, in the result, it is cos alpha minus cos beta, sine beta minus sine alpha. But we have it the other way. We have cos beta minus cos alpha, and then we have sine alpha minus sine beta. So you can change the signs in both the numerator and denominator. In both the numerator and denominator, see, you can understand in different ways. You can multiply the numerator and denominator with a minus sign. Okay, when you multiply the numerator and the denominator of the minus sign, so z and z gets cancelled. When you multiply both the numerator and denominator of the minus sign, or minus 1 or minus, so what will happen? Minus cos beta, minus into minus plus cos alpha, minus sine alpha, minus into minus plus sine beta. So when you have x minus y by a minus, okay, 1 minute. If you have y minus x by b minus a, you can just write it as x minus y by a minus b. You can make the changes in both the numerator and the denominator without changing the value of the expression. This is the final result. Yeah, please write down, children. You can see it again. Write down. Completed, children?
No, ma'am.
Okay.
Completed, ma'am.
Yeah. Okay. See this one. The angle of elevation of a cliff from a fixed point is theta. The angle of elevation of a cliff from a fixed point is theta. So a cliff is a mountain. So see the mountain. This is what we'll be representing. This line segment is what we'll be representing. That is the maximum height of the mountain from the ground. This is the peak of the mountain, right? This is the peak of the mountain. So this line segment will represent the height of the mountain. The height of the mountain. So that's what we'll be representing here. So this one is the height of the mountain. And this is the peak of the mountain. This is the ground level. From this point, when an observer looks at the the mountain top, there is a peak of the mountain. The angle is found to be theta. The angle is theta. The angle of elevation of a cliff from a fixed point is theta. So this line segment represents the height of the cliff. This is the ground level. This is the observer. He looks at the top of the mountain. So this is the line of sight. And the angle between the line of sight and the horizontal is the angle of elevation, which is theta. On going up a distance of k meters towards the top of the cliff. So now the observer is walking up the mountain, walking up the cliff. So after covering a distance of k meters, he walks up the cliff. He covers a distance of k meters. So this distance is k. This distance is k. He stops. He stops and again he looks at the top of the mountain. So he stops here. So that means this will be the horizontal. This will be the horizontal because the horizontal is always a line drawn through the eye of the observer. The height of the observer is not known. So this is the position of the observer and also regarded as the eye of the observer. This is the line through the eye of the observer, which is the horizontal. Now from here, he looks at the top of the mountain. So this is the line of sight. This is the line of sight. Observer to the top of the mountain, line of sight. And this is the horizontal. So this is the elevation. The elevation is now found to be phi. This one is phi. I told you phi, phi. Okay. After going up a distance of k meters towards the top of the cliff at an angle of phi, it is found that the elevation is, sorry, I mistook, at an angle of phi. This one is, sorry. He walks up at an angle phi. This one is phi. This angle is phi. The elevation is alpha. This is the elevation, which is alpha. Okay, since I just confused you, let me do it from the beginning again. Cliff, ground, observer, top of the mountain, elevation, theta. The observer walks up the cliff. He walks up, making an angle phi with the horizontal. This one is phi. He walks up the mountain, he walks up the cliff. The angle which the slope on which he walks, the angle which the slope makes with the ground, that is phi. That is phi. He walks up k meters. The distance covered is k meters. He stops here and he again looks at the top of the mountain. So since he stops here, this will be the new horizontal. And this one is the line of sight. This one is the line of sight. And the angle of elevation is found to be alpha. Angle of elevation is alpha. Phi is the angle which the slope on which he walks makes with the ground. That is phi. Show that the height of the cliff is given by this expression. Show the height of the cliff is given by this expression. So you can just complete it. You can just complete the rectangle, drop this perpendicular to complete the rectangle. And also to complete this triangle. You can drop this perpendicular to complete this rectangle, to complete this triangle. Okay, so that's what you see here. So this angle is theta. This angle is theta. This is the elevation of the top of the cliff. That's theta. This is the slope on which the observer walks. The distance covered by him is k meters. So k. The slope on which he walks makes an angle of phi with the ground. He walks up k meters and he stops here. So this will be the horizontal. And this is the line of sight because he again looks at the top of the cliff. The elevation is found to be alpha. We need to show that the height of the cliff, this one, the height of the cliff is given by this expression. And I told you, complete the triangle, complete this triangle, complete this rectangle by connecting the points F and E, not F and E. So by dropping this perpendicular and mark this point as E. From F, you draw a perpendicular. Let it meet the line segment DC at E. So this is the figure. Now, how do we work this? Okay, I've done it in two ways, but today we'll see only one method. Yeah. So what I want to tell you is that this result, to find this result or to prove this result, we'll be making use of this triangle. We'll be making use of this triangle. This triangle. All right. Now we'll make use of this triangle in order to get this result. Now, what are the different ratios that we have to find? Now for this phi, okay, we have three angles, theta, phi, and alpha. In this figure, we have three angles, theta, phi, and alpha. What are the ratios you have to use? You have to, for phi, you'll have to find both sine phi and cos phi. For phi, you'll have to find both sine phi and cos phi. For alpha, you'll have to find cot alpha. But for theta, okay, for theta, cot theta. So no tan here. So for theta and alpha, it is cot theta, cot alpha. For theta and alpha, it is cot theta, cot alpha. And for phi, you'll have to use sine phi and cos phi. Okay. Now, look, take up this triangle, children. 1 minute. I don't want to use this slide. I'll just copy the slide once again. Yeah, children. I'll just write down the ratios we need for phi, sine, and cos. Okay. We need to find sine phi, cos phi, cot theta, and cot alpha. All right. Fine, children. So now take up this triangle. In triangle AFB. AFB. Take up the triangle AFB. Now for alpha there you'll have to use cot alpha. So what is cot alpha, children? Tell me. I want your help, please. Please communicate. Cot alpha is equal to
FB by AB, ma'am.
correct. Thank you. Yeah. Adjacent by opposite. FB by AB. Now FB is equal to which line segment? FB is equal to which line segment?
EC, ma'am.
EC. AB is equal to, AB can also be written as, AB can also be
AC minus BC.
AC minus BC, correct. AC minus BC. Continue. Can the EC can be written as
BC minus DE.
DC minus DE divided by AC is AC minus BC can be written as BC is equal to opposite sides are equal. In a rectangle, opposite sides are equal. So BC is equal to
P.
FE.
FE. FE. We'll write this again. So in right triangle AFB, cot alpha is equal to adjacent by opposite. So FB, as you all said, FB in a rectangle opposite sides are equal. So FB is equal to EC. AB can be written as AC minus BC. Further, EC can be written as DC minus DE. AC is only the height of the cliff. Let that remain AC minus what is BC? BC is nothing but FE because opposite sides of a rectangle are equal. So BC is equal to FE. Okay, so stop here. Now we found cot alpha. Okay, now find the others. Find sine phi. In which triangle do you have phi? Tell me the triangle in which we have this angle phi.
DEF.
DEF. In triangle DEF. What is sine phi? Sine phi is equal to
FE by FD.
FE by
FD.
FD. That's nothing but K, right?
Yes, ma'am.
Yeah, FD is nothing but K. So sine phi is equal to opposite by hypotenuse. Opposite is FE and hypotenuse is K. Now find FE because see what we're going to do, we are going to substitute here. In this expression, we are going to substitute. Okay, so now we need FE, no? See here, we need FE. So cross multiply and write FE. What is FE? FE is equal to K sine phi. Now from the same triangle, find cos phi. What is cos phi?
DE by DF.
Correct. DE, adjacent DE by DF. And DF is nothing but K. Now cross multiply. So what is DE?
K cos phi.
K cos phi. K cos phi. So see this DE here. We are going to substitute here. Next, we'll have to find cot theta. That is in triangle We have to find cot theta. Theta is the elevation of the top of the cliff from the ground. Theta is the elevation of the top of the cliff from the ground. So in which triangle is theta? In the whole triangle, ADC.
ADC.
Yeah, or
ADC.
ACD. Correct, correct. So for theta, we have to use the ratio cot. So cot theta is equal to what?
AD by DC.
DC by AC.
Correct. Cot theta is equal to DC, adjacent by opposite AC. Now DC is what we need to substitute. See here we have DC. So what is DC? DC is equal to AC cot theta. DC is equal to AC cot theta. Now use all this. Use all this in this, equation. 1 second. Yeah. So maybe you can call this one as 1, this result as 2, this result as 3, and this result as 4. So you're going to use, okay, using the results we got in 2, 3, and 4 in 1. We're using the results we got in 2, 3, and 4 in 1. In the result we have in 1. Okay, what do we get? So we have cot alpha is equal to, what is it actually? Cot alpha? Cot alpha is equal to DC minus DE upon AC minus FE. So that is equal to, what is DC, children? From 4.
AC cot theta.
AC cot theta minus DE.
K cos phi.
K cos phi. AC. AC is AC because AC is what we're finding. No, AC is, we'll have to show that the height of the cliff is given by an expression, that expression. So AC is AC only. AC minus FE.
K sin phi.
K sin phi is equal to cot alpha. So now cross multiply, children. When you cross multiply, you get AC cot alpha minus K sin phi cot alpha is equal to AC cot theta minus K cos phi. This is what we get on cross multiplying. See, we have to show that the height of the cliff is given by that expression. With height of the cliff is nothing but AC. So you're working for AC. You're working to get an expression for AC. So have all the terms that contain AC on one side and the other terms on the other side. So these are the two terms that have AC. Have them on the same side. AC cot alpha minus AC cot theta is equal to K sin phi cot alpha minus K cos alpha. There are 4 terms, 2 terms in the LHS, 2 terms in the RHS. Gather the AC terms. So AC cot alpha minus AC cot theta is equal to, this term is transposed to the RHS. So K sin phi cot alpha minus K cos alpha, which is already there in the RHS. Now take out AC common. You're working to get AC. So take out AC common. AC common. So you have cot alpha minus cot theta. On the other side, you have K common. K common. So take it out. So sin phi cot alpha minus cos phi. So now AC is equal to K into sin phi cot alpha minus cos phi divided by cot alpha minus cot theta. If supposing these two terms are exchanged, then exchange these two terms also. In the numerator, if the two terms in the numerator, that is sin phi cot alpha minus cos phi, if they're exchanged, if the places are exchanged, then exchange the places of the terms in the denominator also. This is how we get the result. So what you need to understand is this is a standard question, children. If this question is asked, it will be like this itself. There will be no changes here. Maybe the angles alpha, theta, phi may be used differently. Otherwise, the information will be the same. So the standard question. So the working will be this. Make use of this triangle. Make use of this triangle. We have alpha in this triangle. And for alpha, you'll have to find cot alpha. So find cot alpha from this triangle. Here, find cot alpha from this triangle and work the changes till as much possible. We got FB by AB and then we kept replacing with the equivalent line segments. And that's how we got this result one. Then find the other ratios, cot theta, sin phi, and cot theta, cos phi, and sin phi from the other triangles. So see, when you find sin phi, you get this. Cross multiply and find Fe from this. Find Fe from this, which can be substituted here later. Then when you find cos phi, you get this one. Cross multiply and write DE. Find DE, which can be substituted here later. DE here. Then when you work cot theta, you get DC by AC. Remember, AC is the height of the cliff. So AC can be AC. That's what we are finding. We have to find the expression for AC. So you don't have to substitute AC with something. We want AC. We don't want to lose AC. We want to have AC. So AC is AC only. So cot theta is DC by AC. Cross multiply, we get DC is equal to AC cot theta. And this DC will be substituted here later. So see, we've got an expression to be substituted for DC, DE, and FE. AC will remain AC. So when you put all these expressions in this one here, cross multiply and collect the AC terms on one side, take out AC common, you will easily get the expression which is to be proved. So this is exactly what is worked here, children. Yeah. Let's show you. So see here, this is the triangle cot alpha, that one. You can see it here. Then we have found EF, DE, CD. So we've called these results 1, 2, 3, and 4. And then you can see using 2, 3, and 4 in 1. This is that main thing, 1. Using 2, 3, 4 in 1, we get, yeah. Cross multiplying, collecting the AC terms on one side, taking AC common. And I also said, see here, in the result, you can see, look at the positions of these terms. We have it in the reverse order here. So simply see, this is like B minus A. Write it as A minus B here. This is like D minus C. Write it as C minus D here. If you have B minus A by D minus C, you can write it as A minus B by C minus D. Yeah, just explain this one. Children, one more and we'll finish the questions in this presentation. So I'll share this image on WhatsApp. All right, and let me explain one more. This one. Okay, I'll share this one on WhatsApp and this one We haven't discussed in the class, but it's very similar to see the seventh one. The 7 and 8, they're very similar. You can see from the diagram. The information is different, but the diagram is the same, and hence the working also will be the same. We discussed the seventh one. Remember the milestones? We worked it in 2 different ways. The seventh one, which is about the 2 consecutive milestones observed from an aeroplane. We worked both the ways. 8 is similar to the seventh one. So we haven't discussed, but I'll share the image. You can understand and help yourself. I'll explain the ninth one. With this, we'll finish all the 11 sums in this presentation, which includes all the standard problems you can get. So another 5 minutes, we'll wind up the session. So in this one, a tower subtends an angle alpha. A tower subtends an angle alpha at a point A in the plane. So say this is the tower. The tower subtends an angle. So how do you show this diagrammatically? These are the endpoints of the tower. This is the bottom of the tower. This is the top of the tower. This is the point A on the ground. The tower subtends an angle at this point A. That means you must join the ends. You must join the ends, meaning you should join the top. You should join the top of the tower and the foot of the tower to the point A. This is the top of the tower. This is the foot of the tower. This is the point A. This is the top of the tower. This is the foot of the tower. This is the point A. Join the top of the tower to the point A. Join the foot of the tower to the point A. This is the angle subtended. This is the angle subtended by the tower at the point A on the ground, similar to that balloon sum. Top of the tower, foot of the tower, and that point A is on the same plane as of the foot of the tower. That point A, the point A and the foot of the tower, they are in the same straight line, is given in the question. So this is the top of the tower, this is the foot of the tower, this is that point A. Join the top of the tower to the point A, foot of the tower to the point A. This is the angle subtended by the tower at the point A on the ground. Now join this tower. A tower subtends an angle alpha at the point A in the plane of its base, and the angle of depression of the foot of the tower, at a point B meters just above A is beta. Okay, so we'll do it one by one. We'll have to take a point which is B. We'll have to take a point which is just B meters above A. This is A. This is A. So this is the point. This is the point which is B meters above A. This is the point A. This is the point which is B meters above A. Let's call that point B. Now from here, you're measuring an angle of depression. So take the horizontal. Take the horizontal. From this point, what are you looking at? You're looking at the foot of the tower. This is the foot of the tower. So join, this is the line of sight. This is the horizontal, and this is the line of sight. Because from that point B, which is B meters above the point A, from there you're looking at the foot of the tower. So this is the horizontal, this is the line of sight, and this angle of depression is beta. You'll have to prove that the height of the tower, this is the tower. Excuse me. You'll have to prove the height of the tower is given by beta and alpha cot beta. So I told you in one of the questions earlier, I told you this one is already given in the question B. This one is B, which is given in the question. That means this is also B. Excuse me. Because this is B, opposite sides of a rectangle are equal. This is also B. We have to find the height of the tower. We know a part of its height already, which is B. We have to find the height of the tower. But we already know the height of a part of the tower, which is B. This one we already know. So we only have to find this one. We only have to find this one. Then B plus this answer will be the height of the tower. Okay. Quickly again, top of the tower, foot of the tower, point A, same base. This is a tower. Connect the top of the tower and the bottom of the tower to the point A. So this is the angle subtended by the tower, which is alpha. Take a point B meters above A. This is the point B meters above A. And from here you're looking at something. So take the horizontal. And which is the line of sight from B. You're looking at the foot of the tower. This is the foot of the tower. So this is the line of sight. And this angle, the angle of depression, is given to be beta. Is given to be beta. This angle is beta. So from this triangle, children, from this triangle, you have to use these ratios. For alpha, it's tan alpha, and for beta, it is cot beta. So use the same ratios, cot beta. From this triangle, cot beta is equal to adjacent by opposite, x by b. So x is equal to b cot beta. Why we write x is equal to? Because we have b cot beta in the result. We have b cot beta in the result. We don't want x. What you don't want to keep on one side, what you want to keep on the other side. So we don't want x. So keep it on one side. X is equal to whatever you want on the other side, b cot beta. Now take the other triangle and find tan alpha. Tan alpha. So tan alpha is equal to opposite by adjacent. This is tan alpha. This one is alpha. Opposite a plus b. A plus b by adjacent x. Now we know x is now we know that x is b cot beta. B cot beta. We know this is x, b cot beta. So for x, we have substituted b cot beta. Cross multiply. You get a plus b is equal to tan alpha. Tan alpha. We get a plus b is equal to tan alpha into b cot beta. Put the b first. And then tan alpha and cot beta. And what is this a plus b? What is a plus b? A plus b is nothing but the height of the tower. What you have here is a plus b. What is a plus b? This is a and this is b, and a plus b together is the height of the tower. So we got it. A plus b, we've got it. A plus b is the height of the tower, which is CD. So CD is equal to b tan alpha cot beta, which is what we had to prove. Prove that the height of the tower is CD. So prove that CD is equal to height of the tower is equal to. So CD is equal to b tan alpha cot beta. Any questions, children? I'll share the images. Yeah, good. I'll share the images. Please complete it right away, children. Don't postpone, you'll forget it. Take another 20 minutes to half an hour time. Within that, you can definitely finish. Complete this and then proceed with your next task. Online, yeah, all of you are online today. Children, use the emoji, raise your hand. Rajat, Sashank, Danya, Rakshita, Raja, Navya, Krishrutik, Ranjan, Florentina. Are you there, Florentina and Krishmi? Yeah, very good. All right, children. I just want to ask you some more questions. Stop the recording and